Hello, Algebra 2. So we are, this is wild, but we are literally in our last section of the year. So I know this is like video 1 of 3, but yeah, this is our last section of the year. So this is 5-6. This is like we're wrapping up logs now. And it's kind of like all accumulating to this. So we're just going to get into it. So we're basically going to be talking about solving logarithmic and exponential equations. So our first type is a logarithmic equation when you have a log on both sides of the equal sign. So this is our first type, like I said, when you have a log on both sides of the equal sign. And if you look below, all of our examples, there's logs on both sides of the equal sign. Okay, so when we are solving logarithmic equations, where a log equals a log, it's really similar to when we were solving exponential equations and they had a common base. And I'll reference that in a little bit. So our first rule, actually very similar to when you get have a common base, you want to condense it so it's one base on each side. This is the same. Our first rule or first step is to use the log properties to condense the log so there is only one log on each side. So use log properties to condense the logs so there's only one log. I feel like my handwriting has gotten substantially worse over this period of time, which is weird because I've still been writing, but I guess just not as much. So use log properties to condense the log so there's only, did we really need it? One log on each side. So that's really your first big step is you want to get it so there's one log on each side. Okay, so once we've done that, we then set the arguments equal to each other. And I should actually, while I'm doing this, I'm actually going to just do a problem. So why don't we just start with one as I go through the steps. Okay, so number 1, we already have one log on each side. However, the one thing that we would want to do is apply my power property. So I'd want to take this 2 and move it to the exponent. So I have log base 5 of now x squared equals log base 5 of 81. Now, if you notice, we have log base 5 of x squared equals log base 5 of 81. So the logs with the base are the exact same. So this can only work, and I guess maybe I should reference that, make note of that. I grabbed 20 pens in one grab. So this bases must be the same, which you guys are only going to have examples where the bases are the same, which is why it was kind of an afterthought. But so now once we have one log on each side of the equation, our second step is to set the arguments equal to each other. So in this step, what we're going to do is our arguments, remember that's like the part within the log. So we're going to set x squared equal to 81. And it's really similar to when we did, when you had, you were solving exponential equations with a common base, right? Because once you got one exponential expression on each side, you set the exponents equal to each other. This is the same thing. We're just setting the arguments equal to each other. And then once you've set the arguments equal to each other, you solve for x. So to undo the x squared, we'd take the square root of both sides, and I get x equals plus or minus 9. Now, our last step, and probably like the place where most people make the mistake, is we need to check our answers. So check for extraneous solutions. And I'm going to explain extraneous in a second. So check for extraneous solutions is relating with this statement down here. So remember the domain of the logarithmic function f of x equals log base a of x is 0 to infinity. That's referencing back to like our old notes when we were looking at the parent function of a logarithmic function. The domain is 0 to infinity. So that's all I'm referencing here. This means that the argument, because the argument is x, right? So this part, x, which is the argument, must be greater than 0. Yeah. This means there can be no negative arguments. So what that means is I need to take both my solutions and plug it back in for x. Now 9, log base 5 of 9, great. That works. It gives me a positive argument. But log base 5 of negative 9 doesn't work. And so that one is an extraneous solution. My only solution here then is x equals 9. So let's write that so we remember. Okay, so negative 9 is not a solution because it causes log base 5 of x, this one up here, to have a negative argument. So you always have to check your solutions when the variable is part of the argument. So all of these, we're going to have to check our solutions. Okay, so what I want you guys to do, I want you guys to look at number 2, and I want you guys to think about what would be your first step in solving number 2. So if you're thinking apply the power rule, you would be correct. So the 1/2 is going to move to the x. The 3 is going to move to the 2. So we're just going to rewrite that. Log base 4 of x to the 1/2 equals log base 4 of 2 to the 3rd power. Okay, so then remember 1/2, a root or like a rational exponent is the same as a square root, right? 1/2 is a square root, 1³ is a cube root, so on and so on. So I can rewrite that. Log base 4 of rad x, and then 2 to the 3rd power is just 8. Okay, so now what would be my next step? And if you recognize, we have 1 log on each side. So now I can set my arguments equal to each other. Rad x equals 8. Okay, now that we have rad x equals 8, we can start to solve for x. So to undo the square root, I'm going to square both sides. And that gets me x equals 64. I need to double check, does that make any of my arguments negative? Positive 64 isn't going to make anything negative, so that is my answer. X equals 64. And most of my checks are just like kind of like a mental check back. You can always just write it in. Oops, sorry, I kicked the table. So you can always just write it. Like you can, we could plug it in and write the check on the side. But typically most of my checks are just like mental checks. Okay, so let's look at 3. Apparently I decided to get really crazy and put a Y instead of an X. So wild. I know. Okay, so number 3, sorry, I don't know where my life is. Number 3, first thing, we have 2 logs on the left side of the equation. So what we need to do is use our properties to condense it into 1. So I look to see how can I condense that? Well, they're the same base. When there is no base, what base can we assume that's there? And if you're saying 10, you're correct. So we can condense this. This is a plus, and they have the same base. It's supposed to be a 10. Terrible 10. So that means what we can do is rewrite it as 1. Remember, when it's adding, we can combine them by multiplying. I'm not going to write the log base 10 because I don't need it. And I'm going to put the 4 first because it makes more sense. And the right side, we don't really have to do anything with. Okay, so now I have 1 log on each side, and now I can set my arguments equal to each other. And now we're not solving for y, we're not solving for x, we're solving for y. So 4 times y plus 5 equals 72. So what would be our first step? Now, 2 of you could have said 2 different steps. 1 of you could have said distribute, and 1 of you could have said divide. Either way that you do that is totally fine. You're both going to get to the same answer. So if I were to go in and do this, I would probably actually divide both sides by 4. And let's do that because I don't know what that is. 18. So y plus 5 equals 18. If you distributed the 4, you'd get exact same spot. And if like you want to do that in your notes, that's totally fine. Do that in your notes. So then 18, subtract 5 from both sides, and I get y equals 13. Don't forget, you always got to plug it back in and double check to make sure it doesn't make a negative argument. It's not that this number can't be negative. It's that it doesn't make a negative argument. So 13 plus 5 gets me a positive number. So it's good. Like even if it was, let's say we got a -1, well, -1 plus 5 still gets me a positive number there. So it would be good, even though the answer is negative, if that hopefully makes sense. So my answer here is y equals 13. Okay, so that is number 3. Let's look at 4. So 4, I want you guys to think what would be the first thing you would do with 4. And if you are thinking combine the left side, you would be correct. If you were thinking apply the power rule on the right side, you would also be correct too. I would do that in one step. I would do both of those in one step. So I would combine this one. So it's minus. When it's minus, we combine it by dividing. So it's going to be ln. X plus 6 is going to go on top. 5x minus 3 is going to go on bottom. Equals ln 8 to the 1/3. Now remember, 1/3 is the same as a root, right? 3 is in the denominator, so it's a cube root. So I'm just going to rewrite that. I'm going to run out of room, aren't I? And then what is the cube root of 8? Well, the cube root of 8 is 2, so I'm just going to cancel it here. I would typically rewrite it, but because I know I'm going to run out of room, I'm going to write it there. Now I have 1 log on each side. log base e, because it's ln, and now I can set my arguments equal to each other. So x plus 6 over 5x minus 3 equals 2. Now, we'd think, what would be our first step to solving for x? And hopefully you're thinking, multiply both sides by the denominator, which you would be correct. We'd want to multiply both sides by 5x minus 3. So that would get rid of the 5x minus 3 on that side, and then this would be 2 times 5x minus 3. And now it's a pretty straightforward equation to solve. It is, it's a linear equation at this point. So I would distribute the 2, 10x minus 6. I would move the 10 to the other side of the equation. So that would be negative 9x plus 6 equals negative 6. Move the 6 to this side. We're subtracting, so it gets me negative 9x equals negative 12. Divide both sides by negative 9, which then can simplify to be positive, and then it can also simplify even more to be positive 4/3. Now I plug this in, okay, 4/3, and I can just do a quick calculation in this too. So I would do in my calculator, you can always do this if it's a weird number, you're not sure. Remember, you guys can always press that STO, S-T-O, and that stores it as whatever. I always use X. So you could do x plus 6. Okay, that gets me a positive number. You could do 5x minus 3. Okay, that gets me a positive number, and this doesn't have a variable in it, so we're good. So it works. 4/3 is my final answer. And that's it. So our last one is, just a little bit more steps, but it's actually not too difficult. Okay, so first step is to always make sure you get your logs, so you have one log on each side of the equation sign. So I want you to think about what you would do to condense each side, because really we need to condense each side here. And if you are thinking, okay, there's a minus in between, which means we're going to combine it by dividing. Same with on the right side. We're going to combine it by dividing also. So this is going to be on the left side. It's going to be log. There's no base, so we can assume the base is 10. X minus 1 over x plus 6 equals log, no base, we can assume the base is 10, x minus 2 over x plus 3. And now we have one log on left side and one log on right side, so we can now just set our arguments equal to each other. X minus 1 over x plus 6 is going to be equal to x minus 2 over x plus 3. And so now we solve for x, and we think, okay, what would we do to help us to solve for x? And if you're thinking cross multiply, you would be correct. So we're going to cross multiply x minus 1 and x plus 3, and we're going to cross multiply x minus 2 and x plus 6. So x minus 1 times x plus 3 equals x minus 2 times x plus 6. And then I just need to multiply, so I need to distribute. FOIL, do the box method, whatever you guys feel most comfortable with. So x times x is x squared, plus 3x minus 1x is 2x minus 3 equals x squared plus 6x minus 2x is plus 4x minus 12. And then what's going to happen, I'm going to rewrite it up here. So what's going to happen is I would move the x squareds over, but what ultimately ends up happening is they both cancel on both sides. So I'm left with, again, another linear equation. Now, let's say you weren't. Let's say you had like a 3x squared over here. Then you would have to solve by either factoring or by using the quadratic equation or the quadratic formula. So if you were left with an x squared, which we're going to have some of those in our next problems, you would solve, like I said, by factoring or quadratic formula. Okay, so then I would subtract the 4x, and I would have negative 2x minus 3 equals negative 12. Add 3 to both sides. Negative 2x equals negative 9. Divide both sides by negative 2, and I get x equals 9 halves. And I want to double check. So what I would do is just like I did before. So 9 halves, I would store it as x. So we're storing 4.5. You could do it mentally. 4.5 minus 1 is 3.5, positive. 4.5 plus 6 is 10.5, that's positive. 4.5 minus 2, that's still positive. And 4.5 plus 3, that's positive. So my final answer is 9 halves. And that's it. So that's our first type. When you have a log equal to a log, you set the arguments equal to each other. So really, really straightforward. When a log is equal to a log, condense, set the arguments equal to each other. And that's it. So we'll get into the second type in the next video. Hope you guys have a great day. I will talk to you literally in the next video. So, but go get a snack. Do what you guys need to do. Watch a TV show. Watch some Bravo. There you go. That's how I feel. Have a good day, guys.